Hello and welcome to this video by Adrian Davey from Pure Electric. In this video, I'm going to talk you through S-plan boiler wiring, possibly even Y-plan. And the reason for that is there's a lot of electricians that don't seem to understand the basics of boiler wiring. And I think any electrician worth their salt should be able to wire a boiler. I mean, after all, if the plumbers can do it, why can't we? You're only dealing with 4 types of cable. You're talking CPCs, you're talking neutrals, you're talking permanent lines, and you're talking switch lines. 4 types of cable. Once you've terminated all your earths and your neutrals, then all you're left with is permanent line or switch line. It's as simple as that. So I'll talk you through the basics. The first thing you need to realise is that if I had a switch fuse spur and a boiler, that would be a very basic wiring system, okay? The only downside now is that I have to stand here switching this on and off for the boiler to come on. Now, I don't want to be standing there all day, and also as well, when I'm not here, I don't want the boiler to be on, but when I get home, I'd already like it to be pre-warmed, okay, rather than having to wait 20 minutes, half hour for that to happen. So the first thing that you're going to need is a timer. So I'm going to open this up here, and I'm going to put in a timer. Also known as a programmer. Now, typical timers or programmers come with 2 channels, so it's a bit like a 1-gang switch or a 2-gang switch. I've also got one myself that's a 3 channel because I've got underfloor heating. So, and that's the same as a 3-gang switch. But we're going to keep this simple to 2 gangs. I'm going to take this link out here for a second, okay? And I'm going to have heating, and I'm going to have hot water. Okay, so I've got HTG at the top for heating in red, and at the bottom I've got HW hot water in blue. So at this point, the channels split, okay? So heating and hot water are separate from each other. The first thing that you need on your heating circuit is something to control the temperature, because if I don't, then it could get up to silly degrees Celsius in here and we're walking around in shorts and t-shirts. So the first thing we're going to put in is some kind of thermostat. So on the heating, we're going to have a room stat, okay? Now, a room stat is essentially just a switch. That's all it is. So exactly like you would draw in any other wiring diagram that you've ever drawn, I've got a switch, okay? I'm going to have exactly the same setup on the hot water side, except this time I'm going to call it a cylinder stat, and it's going to be bolted to the cylinder. Well, not bolted, but, you know, connected to the cylinder. So here, and again, it's just a switch, okay? Cylinder stat. After the stat, we then need something that's going to open up the water pipes, and then to switch on the pump, and then that way water is going to flow around that particular part of the circuit, okay? So the first thing I'm going to need up here for this one is a heating valve. So I've got a heating valve, and again, it's just another type of switch, and I've got a cylinder. And then down here, I've got a hot water valve. So again, hot water valve. So if I just connect this up, I'm going to have the switch line to the room stat. When the heating comes on, that's then going to become another switch line to the heating valve, like that. And then when this heating valve comes on, that is going to come down here and it's going to switch on the boiler. Exactly the same principle with the hot water. I'm going to have a switch line from here. That's going to come down to the cylinder stat. When the cylinder stat's calling for heat, that is then going to switch line to the valve. When the valve switches on, that is then going to go up to the boiler. Now, what tends to happen is that when the boiler comes on, two things happen. The boiler comes on, and so does a pump. Okay. So I'll go through that again. We've got a permanent supply to the timer or programmer. We've got a two-channel programmer, so I've got heating and hot water. The channel is basically the same as a game switch, so I've got a two-game switch. One does one thing, one does another thing. The heating goes to the room stat, so I've got a switch line to the room stat. If the room stat's calling for heat, I've got a switch line from that to the heating valve. If the heating valve opens, then I've got a switch line from there to the boiler. Boiler fires up, the pump comes on at the same time to move the water around the system. The hot water system has a switch line that goes to the cylinder stat. From the cylinder stat, I've got a switch line that goes to the hot water valve. From the hot water valve, I've got a switch line that goes to the boiler and the pump, and then both of those come on at the same time. Sometimes you have a pump overrun, and if that's the case, the pump might come directly out of the boiler, but the manufacturer's instructions will state what needs to happen, and then the boiler controls what happens with the pump. But effectively, it's exactly the same thing. Okay, when we talk about fault finding, if you've got a fault when it doesn't matter whether hot water or heating is switched on, or even if the programmers are calling for heat, then your fault is here. Okay, so fault happens when heating or hot water are off. Okay, if that happens, then you're in this part of the circuit between the switch fuse spur and the timer and the programmer. Okay, so if nothing comes on, then chances are you've got a cable that's connected loosely or wrongly, and we haven't got that switch line, that feed coming through. If it's tripping out the fuse, then we've got a short between live neutral or live earth or neutral earth, okay, which is causing the fuse to trip out. If you've got a fault that only happens when the heating comes on, so fault happens when heating is called for, then you're in the top part of the circuit. You are in the between the hot water, the heating out, the heating terminal of the timer, of the programmer, to the room stat, between the room stat, the heating valve, and from the heating valve down to the boiler. That's where your fault is going to be. If you've got a fault that happens when only the hot water comes on, so heating is fine, but only hot water causes the fault, then you're here. So fault occurs when hot water is called for. Okay, so you're able to find which part of the circuit you're in purely by which item of equipment is calling for heat. So if you're in the hot water circuit, then you just need to focus on that. If it only happens when the heating's on, then you only need to focus on that part. Okay, and then at the very end, we've got the boiler and the pump. So then if the fault happens when either heating or hot water are called for, then you must be at the end of the circuit. So fault occurs when heating or hot water are called for. Okay, then you're in this part of the circuit. Okay, and it's as simple as that. So just to clarify, If the fault happens when nothing's happening, basically there's no heating being called for or no hot water being called for, then you are here between the switch fuse spur and the timer or the programmer. Okay, and you need to then do some fault finding here. If it happens when the heating is called for, then you're in the heating circuit. So we're between the switch line of the programmer, the room stat, the heating valve onto the boiler. So we're in that part of the circuit. If it happens when the hot water's on, then you're in this part of the circuit. And if it happens when either hot water or heating are on, then you're in this part of the circuit. Okay? If you're doing your AM2, then effectively what you've got is your wiring center. And then each one of these is a spur from that wiring center. So I've got switch fuse spur, I've got timer or programmer, whatever you want to call it. Okay, I've got a room stat. I've got a heating valve. I've got the boiler. I've got the pump. I've now got the cylinder stat. And I've got the hot water valve. Okay, so everything is a spur to that, okay, a radial circuit. And then the wiring center is where you connect everything up. And that's what I'm going to talk through in a second. I'm going to show you how to connect up that wiring center. Now in the AM2, you have to say which part of the circuit the fault is in. So if I was to label this wiring center as point number 1, okay, and then the switch fuse spur was 0.2, the timer was 0.3, the room stat was 0.4, heating valve was 0.5, boiler is 6, pump is 7, cylinder stat is 8, hot water valve is 9, okay? Then my fault is ever going to be between the wiring center, so 0.1, and an accessory. And it will either be a short circuit between live neutral, neutral earth, live earth, or should I say line, or it's going to be a switching issue. So basically something's not coming on. Okay, so if the fuse is tripping out, it's a short circuit. It's going to be between one of the conductors. So line neutral, line earth, neutral earth. If it's system staying on, so nothing's tripping out, but something's either permanently staying on or it's not coming on at all. Well, if it's permanently staying on, that means that I've run a permanent live line to it rather than a switch line. Okay, something's crossed over. Whereas if it's not coming on, then there's a fault, basically with continuity between the points. Again, I'm rushing through this a bit, so hopefully this is making sense to you. If it's not, please just leave some comments and I'll tighten this up later on. Like I said, I'm in a bit of a rush to get through this, but essentially that's where we are, okay? Now, if we're then wiring this up, okay, so I'm just going to wipe this off and simplify this board a bit because obviously we've got quite a bit on here. Let's wipe off this. Let's wipe off when the faults occur. Which part that is. Okay. So now we're just left with our simplistic flow diagram. Okay, because this is how it flows. It goes from here to here, from here to here, and all the way through. That's the flow diagram, helps you understand it. If I was then connecting this up, I would have a series of connector blocks. So basically, I've got a row of connector blocks. I'm going to leave out the neutrals and earths to this because it's going to complicate things, but essentially you need a neutral and a CPC to every item of equipment. Okay, so let's say this terminal is the permanent line. We've got earth and neutral. Okay, So we've got, this is your permanent. Okay, permanent line, neutral earth. Like I said, I'm going to leave out the neutrals and the earths because you need those at every point anyway, but it just complicates everything. And when you come to connect up a wiring center, what I suggest you do is get rid of the neutrals and earths first, because then you've pretty much got rid of half your cables, maybe even more than that, maybe 60% of your cables. And then all you're left with is permanent lines and switch lines, and then it makes it easy. The first thing that I need to power up then is the programmer. So I'm going to take a permanent line out of here, and I'm going to run that to my programmer. Okay. Right. Obviously, the neutral and the earth would go there as well. From there, then, I'm going to have a switch line for my heating and a switch line for the hot water. So let's do the heating first, and I'll do that in red. I'm going to have a switch line from the programmer to here. Okay. I then am going to run that to the room stat. So down here, I'm going to have a room stat. Okay. And I'm going to have a switch line from there, because again, everything has to go through the wiring center first. So I can't just go straight from there to there, because everything goes to the wiring center. This is the wiring center. So cable goes from the programmer to the wiring center, from the wiring center to the room stat. And then I'm going to have a switch line back. Okay, so that's going to be my switch line. That is then going to go to a heating valve. So heating valve. I'll tell you what, I'll even do that as a switch, just so you can see what's going on. And I'll do the same with this. I'm then going to have a cable from the switch line from the room stat, which is going to go into the heating valve. And then from the heating valve, that's going to come back. Okay. And then from there, that's then going to connect into the boiler. So, boiler. That's going to go to the boiler. And then at the same time, I want the pump to come on. So I'm going to have another cable that the pump is going to connect into. Okay. And that is the heating side sorted out. Now I'm going to do the exact same thing, but with the hot water side. Okay, so first thing that we need then is a cylinder stat. Now I'm going to start from this way, so that when we work back, we're going to be connecting back into these terminals here. So I need hot water valve, cylinder stat, cylinder stat. So I need to come back to here. Cylinder stat. From the programmer, I need a cable, and that cable, in fact, you divert that, we'll start from this side, that's going to come into here, okay? From that connector block, I'm then going to go into the cylinder stat. So actually, let me put the switch in there, so you guys can see what's going on. Like that. So this is the hot water valve. That's going to go to there. Then from there, it's going to come back into the wiring center. Okay. From there, it's then going to go into a hot water valve. So down here, I'm going to have a hot water valve. Again, it's just a switch. Now, obviously, I'm using blue, but that's not the cable. I'm just indicating that that is the circuit. to match up with this. Okay, obviously you would use the right colours. Now, it's worth pointing out actually that in a boiler system, you don't need to sleeve all the conductors. The colours for a boiler system are whatever the colours are that have been designated. So from here, that's going to come down to the hot water valve. From the hot water valve, that's then going to come back up to the wiring centre. From there, that is then going to connect into the pump and boiler. So from there, that is going to go round here into there. And then that is going to fire up both of those. Now, you're also going to need, obviously, like I said, a neutral and earth at each one. You're going to need a neutral. You're going to need an earth. At the heating valve, again, you're going to need a neutral and earth. So all you're going to do is you're going to come from here into here. So we need a neutral. We need an earth. The other thing that you're going to need on a heating valve is something that's then going to switch it on. Okay, so you need a permanent line. So I'll just call this PL, permanent line. Okay. Boiler, you're going to need possibly a permanent line, but you're definitely going to need a neutral and an earth. Same for the pump. You've got your switch line coming into the pump, so the pump is going to need a neutral and an earth. Your hot water valve is going to need earth, neutral, permanent line. And same for this hot water valve up here. This is going to need neutral, permanent line, and an earth. Room stat is a room stat could need a neutral, make them more accurate. Some don't need a neutral, they just line in and line out. But if it's any kind of sort of digital affair, or it's a more accurate so rather than a bimetallic strip, it's actually an electronic one. It's going to need a neutral. So here we're going to need neutral, and you should always run a CPC to every point anyway. So we're going to need an earth. Now, if it is an electronic thermostat, you may need a permanent line there, but that's easy. You just run a cable back to the permanent line like this. And that is essentially a boiler wiring diagram for an S-plan. Now, a Y plan is slightly different because you've only got one valve. All it means is there's an extra switch wire in the valve.